right, so yesterday we learned our last method of solving quadratic equations, and that was with the quadratic formula. Today we're going to spend another day just practicing because that is such a complicated formula. The more you practice it, the better you're going to get at it. So as a warm-up today, I have a quadratic equation that's solved using the quadratic formula, and there's a mistake somewhere in this problem. No solution is not the correct answer. So pause your video and see if you can't find the mistake. All right, hopefully you found that mistake. Maybe it took you a little bit, but the big idea here, this is one of the most common mistakes, is with the negatives. So if they went through and looked at those negatives, said, okay, 2 negatives makes a positive. Yep, positive 3 in the next step. Negative 3 squared, 2 negatives make a positive 9 in the next step. That's good. But here I have negative 4 times 1 times negative 5. A negative times a negative should be a positive, right? This should really be x equals 3 plus or minus the big square root of 9 plus 20 all over 2. And so that would really be x equals 3 plus or minus the square root of 29 over 2, and not a no solution. Now we can't reduce the square root of 29, so this is actually the final answer, but just be careful. A lot of people end up with a no solution when it shouldn't be, because they miss those 2 negatives in there. So if you aren't sure, you feel like something is wrong, you got a no solution, go back and double check that you did your negatives right. That is the most common mistake with quadratic formula. All right, so other than that, we're just going to keep practicing using the quadratic formula, right? Maybe as a quick refresher here, let's write down that quadratic formula so we have it. X equals negative b plus or minus big square root sign. Inside I have b squared minus 4ac, and the whole thing is divided by 2a. All right. Now, if you remember from yesterday as well, the a, b, and c come from our quadratic equation when it's written in standard form, right? Standard form was ax squared plus bx plus c equals 0. The big indicator that's in standard form is if it equals 0, right? And then making sure that our terms are in the right order on the other side. If I look at this problem in number 1, I notice it's not in standard form. It equals negative 12x, not 0. So my first step is going to be to add 12x to both sides, and I'm going to put that 12x right in the middle, right, so that it's in the correct order. So it'll be 2x squared plus 12x minus 54 equals 0. Now it's in standard form. Now, I could jump right into the quadratic equation, but at this point now I want you to start kind of thinking about what would make this as easy as possible, since you know a little bit more about the quadratic formula and you know how complicated it can get, right? I know it's going to be our last resort eventually, but we're still going to practice using the quadratic formula today on all of our problems. What I do notice, which I hope you notice as well though, is all of those terms can be divided by 2. Right? In the last unit, we talked about taking out a GCF, which you definitely could, but when we're solving, when we have an equal sign, let's just divide every single thing by 2. Now, the only time you can do this is if they all divide by 2. If you get a fraction, oh my goodness, don't do that. But here, it's going to make our life so much easier. I'm going to end up with x squared plus 6x minus, 27 equals 0. And now again, remember, if you divide one thing, you have to divide every single term, right? So you can't just divide the first term and the last term. If you're going to divide, you got to divide every single one. Kind of like finding a GCF, you pull that GCF out of every single term. So just make sure that you do everything divided by 2. But I want, at this point, start looking to make your life easier. You could have done quadratic formula right from that red step. A is 2, B is 12, C is negative 54, but your numbers are going to get crazy. So now at this point, maybe you're kind of looking like, oh man, I could factor that. you're right, and factoring would be a lot easier, but we're still going to practice using the quadratic formula today, just to make sure you're really solid with it. So if I look at this, I'm going to find A, B, and C. So A is that invisible 1. B would be positive 6. And C would equal negative 27. Don't forget those negatives go with those terms, right? Those coefficients. All right, so now I'm ready for my quadratic formula. I just like to, again, set everything up with my parentheses where I'm going to put all of my different terms and then start plugging things in. Okay, so let's see, it's negative b, so 6 goes in that first one, plus or minus square root of b squared, so 6 goes in that second one, times, or minus 4ac divided by 2a, so I'm going to put my a's in there, and then c is negative 27, and I've got all my spots filled in. Okay, now I start simplifying, right? So I got x equals negative 6 plus or minus square root, 6 squared is 36. Watch your negatives here now, right? Negative 4 times negative 27 times 1, right? So negative times a negative here is plus, let's see, that would be 40. 4 times 20 is 80. 4 times 108, I believe. You could always type into your calculator, that's fine too. 4 times 27, 108. And then divided by 2. All right. Now I'm going to move up here because I'm ran out of room. So now I'm going to add the 36 and the 108. So I get, oops, I forgot my x equals negative 6 plus or minus big square root. Oh, maybe not quite so big. So let's see, 36 plus 108 is 144 divided by 2. Oh, 144, that's a perfect square, isn't it? So I have x equals negative 6 plus or minus 12 divided by 2. And now, since that was a perfect square, this is when I can split it into two separate equations, right? Negative 6 plus 12 over 2. And I can do negative 6 minus 12 over 2. Let's see, negative 6 plus 12 would be negative 6 over 2. Negative 6 minus 12 equals negative 18 over 2. And then I actually divide. I definitely ran out of space. That's a really light color. Sorry, let's get you a better one. Here we go. So let's see. Negative 6 divided by 2 gives me negative 3. Negative 18 divided by 2 is negative 9. Oh, I apologize. This should be a positive 6, and this should be a positive 3, and then a negative 9. I watched my negatives. See, if something looks a little funny, always check your negatives as one of your first possibilities for things going wrong. All right, so on that one, I wanted you to really think about, hey, you could still look for a GCF even when you're solving using the quadratic formula. It will make your life easier to get that GCF out of there before you plug those numbers in, because it's already complicated if they're smaller numbers, not to mention those huge ones. So look for a GCF. All right, second and final problem we're going to do today. Let's take a look at this one. 4x squared minus 12x looks like I have a GCF. Oh, plus 3 doesn't look like it anymore. Okay, so no GCF, so we're just going to practice using that quadratic formula the way it is, right? So a is 4, b is negative 12, and c is positive 3. All right, get my quadratic formula set up here. B squared minus 4ac, never make that radical long enough, divided by 2a. All right, so it's negative b, make sure you got those parentheses, right? 2 negatives on that one. Negative 12 squared going inside there. A is 4, c is 3. I have everything in the right spots now. Okay. So, all right, two negatives here. When I start simplifying, I get x equals 12 plus or minus, big square root here, negative 12 in parentheses squared. Remember, after you squared, it's always positive. So negative 12 squared is positive 144. Should never have a negative answer for that part. All right, let's see. Now I've got negative 4 times 3. So I only have one negative. So I'm definitely going to still be minus. 4 times 4 is 16. 16 times 3 is 48 going inside. And then on the bottom, 2 times 4 is 8. All right, x equals 12 plus or minus square root of, let's see, 144 minus 48 gives me 96 on the inside, divided by 8. Now, 96 is not a perfect square. So let's see, what perfect square would go into 96? Ooh, I think 16, right? 96 is the square root of 16 times the square root of 6. Yeah, 60 and 36 would give me 96. Yes, okay. So here I have then, square root of 16 is my perfect square. So I'm going to have x equals 12 plus or minus 4 radical 6 over 8. I think I'm going to move this up. Give us a little more room to work. So I'm going to put it up over here. Okay. Now, I see I have numbers outside. Outside the radical, I have 12, I have 4, and I have 8. So if you're good at canceling those out, really think about it. I always recommend that you think of this as factoring out a GCF on the top, though. What would be the outside GCF? It would be 4. So this is really like 4 times 3 plus or minus radical 6 on the top, factoring out that GCF of 4 from my two terms on the top. And then it looks a little bit easier. I know how to simplify the 4 and the 8 on the outside. I won't miss anything. The 4 is going to be gone on the top. It's going to become a 2 on the bottom. So my final answer will become 3 plus or minus radical 6 all over 2 as my final answer. I just wanted to, again, practice one of those where you have a not perfect square that you can simplify, because I know that that is tricky. So, you can simplify the outsides. Remember, you'd have to divide every single outside by the same number, but I just really think it's easier and makes you, catch little mistakes way more often if you just factor out the GCF of the top and then cancel your outsides after that. You'll just not make so many mistakes if you do it. So I wanted you to see one more example like that. All right, that's it. Same wrap up as yesterday because it's the same stuff. So really just practice that quadratic formula, look for a GCF to make those numbers easier. And then, once you get going on that quadratic formula, if you do have a radical that's not a perfect square, remember to simplify it if you can, and then factor out that GCF on the top to reduce the outsides whenever possible.